This video we are going to learn about Cayley Hamilton Theorem. So in this, instead of a characteristic equation, we are using characteristic polynomial. So what is characteristic equation? Like a minus lambda I, which is equals to 0, right? Here characteristic polynomial is det of a minus lambda I. Let us consider this as a p of lambda. So now what Cayley Hamilton theorem says, like p of a which is equals to 0. What is this p of a? How we need to do means we are going to see in the problem. Okay, replace lambda with matrix A in the polynomial, you get the 0 matrix. Okay, now what is the purpose of this CHT means? With this we can find A inverse easily and A power n. Okay, matrix power n, remember this. We can find the matrix power n with the help of the character like Cayley Hamilton theorem. When means when this polynomial satisfies. Okay, let us go direct into the problem. Here verify the CHT and compute a power 3 when a equals to like this. Okay, now first let us go for the characteristic equation. What is the characteristic equation? A minus lambda I. So represent the diagonal like 1 minus lambda, 2, 3, 4 minus lambda. Okay, when you do the determinant for this, you will get like this, like 1 minus lambda into 4 minus lambda, 2 3 are 6 minus 6. Okay, when you simplify this, you will get this thing. And now apply CHT. How we are applying means, just now we have seen, right, like replacing the lambda with the A. When we replacing the lambda with the A in this equation, the equation turns to a square minus 5a minus 2. Here you can write with the I, because when we adding the matrix, here I ignored. When you turning into the matrix, you need to replace with I. Okay, which is equals to 0. Keep this as equation 1. Okay, a square means what is the A given? 1 2 3 4, write in the 2 times, minus 5. What is the A? Write this. 2, I is the identity matrix, like in the diagonal only one presence. Okay, when you simplify this, like when you do so, you will get this thing. When you do, you will get this one. When you do this, you will get this one. Okay, after doing so, you can check that like minus 5 minus 2, which is like minus 7. So plus 7 minus 7 will get cancelled, right? 10 minus 10. Okay, this is also get cancelled. 15 minus 15 will getting cancelled. 20 minus 20 minus 2. Okay, plus 22, which is going to get cancelled. Nothing but it is turning into the 0 cross 2 into 2, right? Like 0 matrix 2 cross 2. Okay, this is nothing but 0 equals to 0. Therefore CHT is verified. Okay, CHT is verified. So this is how you need to verify the CHT, like Cayley Hamilton theorem is verifying in this format. Nothing but replacing the characteristic equation with the given matrix A. Nothing but the characteristic equation is turning into the characteristic polynomial. Now half part of the question is completed. Verify the CHT is completed. Now what we left with? We left with the a power 3. So when the CHT is verified, now we can easily find the a cube also. How means? We have written this as equation 1, right? Take the equation 1 here for the a cube. From equation 1, a square minus 5a minus 2a, which is equals to 0, right? Send these things to the RHS side. When you send means, we are left over with the a square, which is equals to 5a plus 2a. Multiply a on both sides, we will get a cube as 5a square plus 2a. Now instead of finding this here, we can find directly this thing, right? Like 5 into what is the a square? A square here we got this thing, right? So directly keep over here. Now plus 2a plus 2a. When you simplify this, you will get like this. Okay. I hope you got the idea on this question. Let us see one more question. Okay. In this question, we are going to find the A inverse using CHT. The given A matrix is 2, 1, 1, 1. First, let us apply the characteristic equation. Characteristic equation is like this, like A minus lambda I, apply 2 minus lambda, 1 minus lambda. When you simplify this, you will get this thing from this here. Okay. Apply the CHT, nothing but replacing the lambdas with the A. When you replace, so you will get a square minus 3a plus I, which is equals to 0. Perform a square, like a into a minus 3a plus I matrix. When you do so, you will get same 0 cross 2, 2 cross 2 matrix, 0 equals to 0. So CHT is verified. Now let's go for the A inverse. A inverse is from the equation 1 only we are going to find the A inverse. Like taken from the equation 1, what is the equation 1? A square minus 3a plus I, which is equals to 0. Let us keep I over here and send these two things to other side. When you send so, we are getting like minus 3a at the right hand side, 3a plus a square will be the minus a square. Now multiply the a square on both sides. So when we multiply, so here I into a, like I into a power minus 1 will be the A inverse only. A inverse, which is equals to the 3i, like into A inverse minus a square into A inverse, which is like we are left over with I minus a, right? Like 2 minus 1 will be the 1, right? Do so, I means identity matrix 1 1 minus what is the A? 2 1 1 1. Okay. Perform this, you will get the A inverse as 1 minus 1 minus 1 2. Okay. This is how you need to find. I hope you got the idea on this Cayley Hamilton theorem and how we are verifying, and how we are, after verification, how we are going to find the A power n and A inverse. If you learnt anything in this video, please do a like and support by subscribing. Thank you for watching this.